This session is about the analog ultrasonic distance sensor. We'll be using another PWM cable with one end cut off and soldered onto the ultrasonic sensor onto pins 3, 6, and 7. This is the MacSonar MB1013. We will return back to our cumulative robotics project. We'll open Robot CPP, Robot H. This is an analog ultrasonic sensor. We will not be using the digital ultrasonic sensor. If you were to go to the class list and scroll down to ultrasonic under the letter U, ultrasonic, this particular class is designed for use with digital ultrasonic sensors. That's not what we're using. We're using an analog type. This is the data sheet for the sensor. Here, you can use it in digital or analog modes, but we have it wired up as an analog mode. If we go to page 2, we can learn more about what's happening on pin 3, the analog output. In an earlier session, I said that typically we would not use the raw analog to digital value, but it turns out in this case, if we were using a 10-bit analog converter, we could simply just read the number and multiply it by 5, and that would give you the range in millimeters. We're using a 12-bit converter, so we have to adjust for this. Our range is not 0 to 1023, it's 0 to 4095, which means we can read the ADC value and multiply it by 1.25, which is 1/4 of this 5, and that will give us the range in millimeters. Returning back to our project, we can do just this. We could use the analog input that we already created, or we can just create another analog input. We're going to create a second one to stay consistent with our prior documentation. We're going to call this Ultra, and it will be on analog input number 1. It's still an analog input device. We just gave it a name so we know what it is in the code. It's sitting on pin 1. We're going to declare an integer for the read the value. It will be ultra raw equals to 0. We're going to need a few other things. We're going to create a double called distance. We're going to create another number, which we'll just use as a constant. It will be our conversion factor. It will be ADC to millimeter. It will be 1.25. We'll save the H file. Let's go to Robot CPP. We can just ultra raw equals, let's get, we're going to get the value, just the raw value. We can take that number from 0 to 4095. The distance will be equal to the times the, what do we call that other guy? It was the ADC to mm. ADC to millimeter. So we take the raw converter value, multiply it by this value here, and that will give us the number of millimeters. This data type right here is a double. This is an integer. This is a double. We're going to do something for the first time called a cast. And what this expression right here will do, it will take this integer and convert it to a real, take that real number, multiply it by this real number, and take that resulting real number and store it into distance. This is in millimeters. Let's do one more thing just for fun. We're going to put a parenthesis here. And what a parenthesis here. And just like in high school algebra, PEMDAS, we're going to evaluate the inside of this parenthesis and then multiply that by, we're actually going to divide it by 1,000. We're going to put a .0 there, which will tell the compiler that we want this to be treated as a double, not as an integer. So we're going to be converting millimeters to meters. There's another way to do it. We could just go back to the H file here and just make this divided by 1 there and not do it here, which will be a little smarter or easier. We're going to add one more thing to our print, or a couple of things to the print. Let's get, let's go ultra raw. We're going to get the distance. Now let's just print out the distance. And let's see how this goes. I'm going to compile it. Now we're going to deploy it. We have our startup. We have a distance on the board here, and the raw value. We're not enabled yet. Let's enable it. And we got some kind of number here. I'm going to move this thing around. See if I can. Yep, I'm holding a book in front of it, and I'm moving it back, further back, and further back. It has some distance there as I move away. You can see the raw value, the calculated value, and that distance is approximately correct. And that is our analog ultrasonic sensor demonstration.